Hey everyone, happy February break. This is your second flipped classroom lesson for the break. The title is the quadratic formula, and what I would like you to do for your opener is write an equation for the quadratic function represented in the table in the form of y equals ax squared. So we're going to write an equation in this form, and it's standard form actually. We just don't see the plus bx plus c. We can assume those are just 0, and we're going to use this table to do so. We've actually done this question before. It was a question that was on a half sheet of paper that I collected some data on for what all the algebra teachers collected some data on actually, just to see how we were progressing on writing equations. So it may look familiar. Go ahead and try and write this question, try and figure it out, and when you're done, hit play on the video and see if you got it right. So the first thing we do is we notice in our equation that we have y, a, and x, and those are 3 variables, and we can't really solve an equation with 3 variables because that would just give us an equation with more variables. So we can substitute numbers in for our x and our y, which is definitely what we want. So let's do that. I'm going to substitute a point in to help us figure out what our a value is. And let's do this point down here, -5, -75. Remember, you could have plugged in any point you want, but I always pick points that I know will be easy to square, subtract, multiply, whatever we're doing. So let's start with that. Our equation is y equals a times x squared. I know my x value is -5, and my y value is -75. So we have -75 equals a times -5 squared. Rewriting, simplifying our parentheses first. -5 squared, which we talked about last Friday and in the first class lesson. -5 times -5 is 25. We were talking about how the square root of 25 could be 5 or -5. So we would have 25a. And then to get a by itself and balance our equation, we're going to divide by the coefficient on a. So we're dividing both sides by 25, and -75 divided by 25 is -3. So our equation to represent this table is -3, y equals -3, x squared. Perfect, we're done. Easy as that. This is very similar to when we write equations in vertex form, except for we didn't have to pick out the vertex this time. We actually wouldn't have been able to identify it in this case because we can see that our pattern and our y values is still decreasing every single time, and we know that a vertex point is like our point of inflection, where our y values go from increasing to decreasing or decreasing to increasing. So today we just wrote an equation given a table, a really important skill to have and to recognize. And our mini lesson is over the quadratic formula. Your work session will be in class on Thursday. So remember, you don't have anything else you have to do except take this notes page for Thursday. So when we think about what are some ways we have solved to find zeros of an equation, if you just do a little reflection on what we've done, we have used square roots in order to find the zeros of an equation. We've used square roots. We've used completing the square. Completing the square has helped us find those zeros. Those were our most recent ones that have helped us. We've also used factoring. We've used factoring. We've used factoring when a is equal to 1 and when a is not equal to 1. And we've also used factoring for those special cases like our perfect square trinomials and the difference of squares questions. So today we're going to learn another one, and it is called the quadratic formula. It helps us figure out the zeros of an equation. And a lot of people say it's the most complicated way, like the last resort way to use, but if you know the formula, it's really pretty simple. All you have to do is plug in whatever numbers you have and solve the equation. I don't think it's that bad. I don't think you'll think it's that bad either. Aha, but here it is. So here's our quadratic formula. It's x is equal to -b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's break this down just a little bit. The reason why you see this symbol right here, which is not something super familiar to us, this plus or minus sign, it means that we could have a positive square root of b squared minus 4ac Or we could have a negative square root of b squared minus 4ac, and we've talked about that before. Remember, square root of 25, it's 5 or negative 5, so this formula takes into account a positive and a negative root. So all you have to do is, this helps you find the zeros of a quadratic equation. Remember, zeros, roots, x-intercept, solutions, we know this from our tip chart. All of those are exactly the same thing. You substitute your a, b, and c values into the equation, and then you solve. You get your a, b, and c values from that equation right there. All right. Now, there is a song to help you remember the quadratic formula, and I'm going to sing it to you, so feel free to laugh, but it's a song that I learned and I never forget it, and I hope it'll be helpful to you as well. One of your work session options on Thursday will actually be to remake a new song to the tune of a song that you like instead of the one that I'm about to sing. I'm actually, after I sing, I'm going to link another video. I'm going to try to be all YouTube fancy and link another video. It should pop up like right now on the screen, and you can watch that video for someone who made a song about the quadratic formula, but it's with a One Direction song. That was pretty good. So this song is to the tune Pop Goes the Weasel, so it's kind of like a childhood song. But this is how it goes, to help you remember the quadratic formula. It's x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so feel free to sing this on your own several times so you memorize it, because you know I'm going to ask you to. So you might as well just sing the song, and it helps you out a little bit. So think about that song. We're going to be singing it 2 more times in our 2 more example problems that I have. But again, it's a great way to just remember the formula, and you will have an opportunity in your work session on Thursday, if you want, to make up your own song to help you. So let's try a few example problems. I have a step-by-step guide right here on the side, and I have an example problem up here. So given the equation, identify your a, b, and c values. So let's do that off to the side here. Our a value is a 1. We have a 1x squared. Our b value is 4, and our c value is a negative 21. Step 2, substitute said values into the equation. Oh, do you remember the equation? Let's use our song to help. All right, so we've got x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Oh, just never gets old, right? So let's plug in the values for our equation. So I'm going to plug in my values in the color black. I'll keep writing in red. So my negative b value, I have a 4 there, plus or minus the square root of 4 squared. Oop, I should have put the squared in a different color. Hold on. 4 squared minus 4 times my a value, which is 1, my c value, which is negative 21, all over 2 times a, which is 1. Awesome. All right, we're ready to solve. And again, I know this is a long, complicated formula, but I promise after you do a few questions, you will just start to remember it. And they do give it to you on the milestone like formula paper. So for my class, I'm going to have you memorize it, but it'll be there for your use. So let's simplify things one at a time. That's the goal. A lot of people just type this whole thing into their calculator, which you can do if you know how to properly type it in, meaning using parentheses where you should, things like that. But sometimes it's helpful just to simplify piece by piece before you go calculator crazy. So let's start. I'm going to leave the negative 4 for right now, and the plus or minus as well. I want to simplify what's under that square root symbol. So 4 squared is 16 minus 4 times 1 times negative 21. All right, so think about this. If I'm subtracting and I know my product's going to be negative, I know I'm going to have to end up adding here because a negative times a negative makes a positive. So we're doing 21 times 4 times 1. 21 times 4 times 1 is 84. All over 2, just 2, because 2 times 1 is 2. Let's do our next step. And of course, as you're going through this, if you're using less steps, if you're simplifying bigger groups at a time, that's great. We'll do that as we do a few more example problems, but I'm going to break this down a little slower. So now we have 16 plus 84. 16 plus 84. That gives us 100. Ooh, convenient, a perfect square. Divided by 2. So since we're ready to take the square root of that 100, this is where we can separate our equation into the positive root and the negative root. So to show that, we have x is equal to -4 plus the square root of 100 over 2. And then x is equal to -4 minus the square root of 100 over 2. So here we've got -4, square root of 100 is 10. So -4 plus 10. -4 plus 10 is 6 divided by the 2. X equals 3. So we know one of our x's is 3. And when I say 3, that means it crosses the x-axis at 0, or excuse me, 3, 0. Sorry, I was trying to get it so you didn't erase right through the 3. There you go. Second one. So here, where this is our negative root, so the square root of 100 could also be -10. -4 minus 10 is -14 divided by 2. X is -7. So those are the two roots right there. Perfect. We know our quadratic will go through the point x is equal to 3, 0, and x is equal to -7, 0. Yay, you just use your first formula, and you know, it looks like a lot of steps, but again, we'll move through them quicker. You can move through them quicker if you can do that simplification process. Let's try one more. We've got 4 minutes. All right, let's do it. So step 1, identify our a and b values. So we have a is 2 this time. Nothing changes about the way we solve it. B is -3. C is -5. Substitute those values into our quadratic formula. Again, to remember that, x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Woohoo! Let's plug them in. X equals okay, the reason why I picked this example is for all you people who keep having just a couple issues on the negative idea. We have a -3. That our b value is already negative, and we're making it negative as well. So -3 plus or minus the square root of -3 squared, I'm going to put that in parentheses as well, minus 4 times a times c. Our a value is 2, c value is -5. And that's going to work out great. Again, I see a negative and a negative sign. I know I'll just be able to add. Divided by 2 times our a value, which is 2. Let's simplify some groups of numbers here. -3 is a +3, plus or minus the square root. -3 squared is 9. -5 times 2 is -10. Times 4 is -40. But we're subtracting a -40, which is the same thing as adding 40. All divided by 4. So now we have 3 plus or minus 9 plus 40 is 49 divided by 4. Let's split up our roots since we know we're going to have a positive root and a negative root. Over here we're going to have 3 plus the square root of 49 over 4 and 3 minus the square root of 49 over 4. If you're asking yourself, as I split these up, can I just write a 7 instead in this case because the square root of 49 is 7? Yeah, absolutely. Here we'll have 3 plus 7 over 4, and on the other side we have 3 minus 7 over 4. For our first root, if I extend the page a little bit, we have 7 plus 3 is 10, so we have 10 over 4. And 10 divided by 4 will give us a decimal, but you can write it as a fraction 10 over 4, or you could simplify that, or you could write your decimal. I feel like most of you will probably write the decimal, so we can stick with that. Over here, 3 minus 7 will be -4 over 4, and -4 divided by 4 is -1. So the two places that our equation will cross the x-axis are 2.5 and -1. And from our formula, you can also tell that it'll cross right here at -5 on the y-axis. And if we wanted to, we could find our vertex. So we can find everything, those 4 points, to graph any equation. Good job. I'll see you on Thursday in class, remember one of your options will be actually making up a new song for the quadratic formula, so get your mind going on that. Have a good night.